Hello, this is Val, and I'm going to take you through the stages of labor. This is Valentina Boy, Biology and Medicine videos. Please like, subscribe. So today we're going to go through the stages of labor, and the learning outcomes for this lecture are looking at steroid hormones and their mechanism of action, and I guess the progression of labor. So this is what I've gotten so far. Hopefully it's correct. Okay, so starting off with steroid hormones. Just gonna zoom in a little bit here. Okay, so just a note, cholesterol is the precursor to all steroid hormones. It is converted in either the gonads or in the adrenal cortex to steroid hormones, for example, estrogen. And these steroids are all lipid soluble, which means that they can diffuse through a cell membrane and bind to either nuclear or intracellular cytoplasmic receptors. So this is a cytoplasmic receptor here and a nuclear receptor here. And you can see that the estrogen here has diffused straight through to bind to these receptors. And that is as opposed to non-lipid soluble hormones, which would have to bind to a receptor on the cell surface. So what happens after that is that these steroid hormones bound to their receptors form a receptor ligand complex, and these are going to bind to DNA and cause transcription of certain proteins, which is therefore going to initiate a cellular response. So we have cholesterol, the precursor to steroid hormones, which are able to diffuse, bind to their receptor, and together they bind to DNA and initiate transcription. Okay, so now moving on to the stages of labor. Let me just zoom out. Okay, so there we go. So starting in labor, there's a lot of things going on, but we have to remember that it all starts with a developing fetus. So you can see here I've drawn a mother and her developing fetus, and there are a few things that happen here. I've circled the main players in blue, hopefully you can see, but the first one that we're going to look at is cortisol. So what happens is that as a baby grows, it prepares to kind of exit the womb, it's going to increase in the production of corticotropin releasing hormone from its adrenal glands. And this is going to lead to the increased release of cortisol from both the mother and the child. And cortisol itself acts on the placenta, so I've drawn the placenta here. What it does is it decreases the production of progesterone by the placenta and increases the amount of prostaglandins, and we'll come back to that in a second. Cortisol also causes lung development in the fetus and the increase in surfactant production, which is important in preparing the fetus to come into the living, breathing world and breathe some delicious air. So that's cortisol. Another thing that's been increasing throughout pregnancy, that's been produced by the placenta, is estrogen. So remember, estrogen is constantly increasing throughout the pregnancy. And what this does is it increases the number of tight junctions between the myometrial smooth muscle cells and increases the expression of oxytocin receptors, which becomes important later on. Estrogen also decreases progesterone sensitivity. And remember that progesterone was that hormone that was produced during pregnancy to maintain the fetus within the womb. Now, I've also drawn here the fetus within the womb that is increasing as it grows. It's increasing its pressure on the cervix. The cervix is here, and it's a small opening, the bottom part of the uterus, and it's covered by a so-called mucus plug, usually. which kind of protects the fetus and the placenta, etc., from any bacteria. And so what happens when there's an increase in pressure on the cervix is that this is going to send signals to the hypothalamus in the brain, which signals to the pituitary gland to release a hormone called oxytocin. So remember here, estrogen has increased the number of oxytocin receptors on our myometrial cells. Now what oxytocin is going to do is it's going to bind to those receptors and increase the release of calcium from vesicles within the smooth muscle cells of the myometrium. At the same time, estrogen has also increased the number of prostaglandins, which is also one of the effects of cortisol. And prostaglandins increase the activity of calcium channels. So now we have heaps of calcium going into the cells. And if we think back to our sarcomere, which is the subunit of the cell, it requires calcium to cause muscle cell contraction. So therefore, oxytocin and prostaglandins cause increase smooth muscle cell contractility. And this contractility is going to increase the pressure on the cervix, which then sends a signal to the hypothalamus, which then releases more oxytocin, which causes contraction, and so on and so forth. And so this is a very important positive feedback loop that we talk about within pregnancy, where oxytocin causes continual contractions of the myometrium, which eventually leads to labor and birth. So now moving on. Now the next thing we have is the actual 3 stages of labor. So the first stage is dilatation. Dilatation usually occurs after the waters break, aka when the amniotic sac ruptures, and this causes kind of an outpouring of amniotic fluid to lubricate the birth canal. Labor can also begin when the mucus plug is expelled, and this can be kind of seen as a bloody, thick mucus plug or discharge. Now, dilatation as the first stage of labor can be divided into 2 phases, the latent phase and the active phase. The latent phase begins when contractions first start and is defined as the period when the cervix is dilated between 0 to 3 or 4 centimeters. During this phase, the contractions are about 5 to 30 minutes apart, and they last around 30 seconds. So they're short and they're far apart. Then, as the cervix progresses to dilate to 10 centimeters, we enter the active phase, which is where contractions begin every 0.5 to 5 minutes and last 16 to 90 seconds. So now they're longer contractions and they're lasting longer. Sorry. They're longer contractions, but they're shorter apart. They're less far apart. At 10 centimeters is considered the full dilatation of the cervix, and that's when usually the baby's head can be seen. This is known as crowning. Let me just close those quotation marks, because that's annoying me. Okay, so now we have crowning, we have our cervix dilated. Another thing that's happening here is that we have the formation of prostaglandins earlier on, which have a really important role in the dilatation and effacement, that is the thinning of the cervix. So prostaglandins, whilst they're increasing contractility, also help to efface and dilate the cervix. Okay, now moving on to the expulsion phase. So this is the phase where the baby actually yeets out of the uterus and into the world. It has kind of a few cardinal movements of labor, which apparently can be very interesting to watch. Should we ever get to witness a childbirth, which I would love to. So, beginning with engagement. The first thing that happens is, well, the baby engages with labor. And then the second thing that happens is that the baby, the fetus, descends into the pelvic inlet. at this point, we can use something called a station to measure the level of descent of the fetal head. So the station is the relationship of the fetus's head to the ischial spines of the mother's pelvic brim. And so, for example, if the fetus's head is 1 centimeter above the level of the ischial spine, the station would be the station would be -1. And if it was, say, 3 centimeters below the ischial spines, the station would be +3. The next thing that happens, so we've had engagement, descent, and now we have flexion. Flexion is where the chin and the arms of the fetus are fully bent inwards towards the chest. The next thing that happens here is internal rotation, where the fetus does a little spinny spin so that the back of his head, or the occiput, is anterior. So now the back of the baby's head is facing the front. The next thing that happens is, after the baby descends so much so that it passes the symphysis pubis, that is the joining of the 2 pubic bones, it extends its head. That is, it leans its head backwards before externally rotating. And after that, we have expulsion. So now external rotation allows for the head to come back in line with the shoulders. And then we have the popping out of one shoulder, the anterior shoulder, and then the posterior shoulder. And there's a little dance you can do with that where, you engage, you descend, then you flex your head, then you internally rotate, then you extend your head, then you externally rotate, and then you get rid of one shoulder and then the other shoulder. I would also like to mention that expulsion depends on a few things. So this includes the size of the fetus, its attitude, which is not whether or not it's sassy, but how the patient is kind of positioned, like its limbs are positioned. So normally it's fully flexed, that is with its head, its legs, and its arms are all fully flexed. Another thing that affects it is the fetal lie, which would ideally be longitudinal, aka kind of vertically aligned with the mother's spine. However, the lie of the fetus can also be transverse or oblique. Transverse being kind of horizontal, and oblique being anything on an angle. And then another thing that affects it is fetal presentation, which is normally cephalic. Sorry, presentation refers to the position of the fetal head. So cephalic presentation is where the head comes out first, and breech is where the legs are closer to the cervix, and shoulder is where the shoulder is closest to the cervix with the head bent up. In the case of a breech baby, it's often likely that a cesarean section needs to be performed. So after we have expulsion of the fetus, we then have the umbilical cord clamped and cut, and we enter the placental stage of labor, which is kind of the third and mostly seen as the final stage of labor, where the placenta is carefully and fully removed to avoid hemorrhage. And this is a very important process here, and is usually initiated by the body. Finally, after the placental stage, the body starts to return to its pre-pregnancy state, which involves adaptation to blood loss and uterine involution. And uterine involution kind of involves the contraction of the uterus and the reduction of myometrial cells. So that's the stages of labor. I kind of want to film myself doing the dance, but I don't think I will. For this, but you can imagine it, I think. Yeah. Cool. Yeah, that's all. I hope that makes sense. Please let me know if you have any questions.